Corrugated stainless steel tubing, often referred to as CSST, has been the subject of a class action lawsuit. This lawsuit centers around allegations that CSST, when used in gas lines, is susceptible to damage caused by lightning strikes. The concern is that such damage could result in gas leaks and, in severe cases, explosions. The settlement reached in this lawsuit presents two distinct options for homeowners who have CSST gas lines installed in their properties. Firstly, there's the option related to lightning protection systems. This entails a payment towards the installation of a lightning protection system. This system is designed to mitigate the risk of lightning strikes directly impacting the property and, by extension, the CSST gas lines. Secondly, the settlement offers payment for the grounding and bonding of existing CSST installations. Grounding and bonding are crucial electrical safety measures. They aim to create a low-impedance path for electrical currents, such as those from lightning strikes, to safely flow to the ground. This reduces the potential for these currents to travel through the CSST, minimizing the risk of damage. The lawsuit and the resulting settlement are relevant to homeowners and property owners who have CSST gas lines installed in their buildings. To obtain comprehensive information about the settlement, including the claims process and specific deadlines for submitting claims, it is important to consult the designated website. Now we'll delve further into the technical aspects of lightning protection systems and grounding and bonding for CSST. Let's start with lightning protection systems. A comprehensive lightning protection system typically consists of several key components. These include, firstly, air terminals, often referred to as lightning rods. These are installed on the roof of a building and are designed to intercept lightning strikes. They are typically made of copper or aluminum and are strategically placed to provide a preferred path for lightning to strike. Secondly, down conductors. These are heavy-gauge wires that connect the air terminals to the grounding system. They provide a low-impedance path for the lightning current to flow from the air terminals to the ground. Thirdly, a grounding system. This is a network of ground rods or ground plates buried in the earth. It provides a path for the lightning current to dissipate safely into the ground. The grounding system is a critical component of the lightning protection system, as it ensures that the lightning current does not flow through the building's electrical system or other conductive materials. When lightning strikes a building equipped with a lightning protection system, the air terminals intercept the strike and the current is safely conducted to the ground through the down conductors and grounding system. This minimizes the risk of damage to the building and its contents, including the CSST gas lines. Now let's move on to grounding and bonding. Grounding and bonding are essential electrical safety practices that are designed to minimize the risk of electrical shock and fire. In the context of CSST gas lines, grounding and bonding are used to provide a low-impedance path for electrical currents, such as those from lightning strikes, to safely flow to the ground. This reduces the potential for these currents to travel through the CSST, minimizing the risk of damage. Grounding involves connecting a conductive object, such as a metal gas pipe, to the earth. This provides a path for electrical currents to flow to the ground in the event of a fault or lightning strike. Bonding involves connecting two or more conductive objects together to create an electrically continuous path. This ensures that all bonded objects are at the same electrical potential, reducing the risk of electrical shock. When CSST gas lines are properly grounded and bonded, any electrical currents that may enter the gas lines will be safely conducted to the ground, minimizing the risk of damage to the CSST and reducing the potential for gas leaks or explosions. The National Electrical Code, or NEC, provides specific requirements for grounding and bonding electrical systems and equipment. These requirements are designed to ensure that electrical systems are installed and maintained in a safe and reliable manner. The NEC Article 250 covers grounding and bonding requirements. Section 250.104 specifically addresses bonding of metal gas piping systems. It states that metal gas piping systems that are likely to become energized shall be bonded to an effective ground fault current path. This bonding is intended to minimize the voltage on the piping system and prevent electrical shock hazards. There are several methods that can be used to ground and bond CSST gas lines. These include firstly bonding the CSST to the building's grounding electrode system. This can be done by connecting a bonding jumper from the CSST to the grounding electrode conductor or to a ground rod. Secondly, bonding the CSST to a nearby metallic water pipe. This can be done by connecting a bonding jumper from the CSST to the water pipe. However, it is important to ensure that the water pipe is properly grounded. Thirdly, using a listed CSST fitting that is designed for grounding and bonding. These fittings typically have a built-in bonding jumper that connects the CSST to the grounding system. It is important to note that grounding and bonding of CSST gas lines should be performed by a qualified electrician or a licensed gas fitter. These professionals have the knowledge and experience to ensure that the grounding and bonding is performed correctly and in accordance with the NEC and local codes. Now let's discuss some common misconceptions about CSST and lightning strikes. One common misconception is that CSST is more susceptible to lightning damage than other types of gas piping. While it is true that CSST can be damaged by lightning strikes, it is important to note that all types of gas piping are vulnerable to lightning damage if they are not properly grounded and bonded. Another misconception is that a lightning protection system will completely eliminate the risk of lightning damage to CSST gas lines. While a lightning protection system can significantly reduce the risk of lightning damage, it cannot eliminate it completely. It is still important to ensure that CSST gas lines are properly grounded and bonded, even if a lightning protection system is installed. In summary, the CSST class action lawsuit settlement offers two options for homeowners with CSST gas lines. Firstly, payment towards the installation of a lightning protection system, and secondly, payment for grounding and bonding of existing CSST installations. Both of these options are designed to mitigate the risk of damage from lightning strikes. It is important to consult the settlement website for detailed information about the claims process and deadlines. If you have CSST gas lines in your home, it is important to ensure that they are properly grounded and bonded. This will help to minimize the risk of damage from lightning strikes and other electrical hazards. You may consider having a qualified electrician or a licensed gas fitter inspect your CSST gas lines to ensure that they are properly grounded and bonded. They can also advise you on whether a lightning protection system is appropriate for your property. The information provided here is for general educational purposes only and should not be considered as professional advice. It is essential to consult with qualified professionals for specific guidance related to your situation. Understanding the risks associated with CSST and taking appropriate measures to mitigate those risks is crucial for ensuring the safety of your home and family. Remember that proper grounding and bonding are essential for protecting your gas lines from lightning strikes. By taking these steps, you can help to prevent gas leaks and explosions and keep your home safe. Always consult with qualified professionals for specific guidance related to your situation, ensuring all work is performed in accordance with local codes and regulations. In addition to the information already covered, it's important to understand some of the underlying principles that make CSST susceptible to lightning damage and how grounding and bonding address these vulnerabilities. CSST, due to its corrugated design, has a higher surface area compared to traditional smooth-walled gas piping. This increased surface area can make it more susceptible to arcing in the event of a lightning strike. When lightning strikes a building or nearby, it can create a surge of electrical current. This current seeks the path of least resistance to ground. If the CSST is not properly grounded and bonded, it can become part of that path. The electrical current can then jump or arc from the CSST to other nearby grounded metal objects such as water pipes or electrical conduit. This arcing can generate significant heat, which can melt or weaken the CSST, leading to gas leaks. Grounding and bonding work by providing a dedicated, low-resistance path for electrical current to flow to ground. When the CSST is properly grounded, any electrical current that enters the tubing will be safely conducted to ground, rather than arcing to other objects. Bonding ensures that all metal objects in the vicinity of the CSST are at the same electrical potential. This eliminates the potential difference that can cause arcing. Now let's talk about some best practices for grounding and bonding CSST. Firstly, use the correct size of bonding wire. The size of the bonding wire should be appropriate for the size of the CSST and the electrical service to the building. The NEC provides guidelines for determining the correct size of bonding wire. Secondly, make sure the bonding connections are secure. The bonding connections should be made with listed connectors and should be tightened to the manufacturer's specifications. Loose or corroded connections can increase the resistance of the grounding path and reduce its effectiveness. Thirdly, protect the bonding wires from damage. The bonding wires should be protected from physical damage, such as being crushed or cut. They should also be protected from corrosion. Fourthly, inspect the grounding and bonding system regularly. The grounding and bonding system should be inspected regularly to ensure that it is in good condition and that all connections are secure. Any damaged or corroded component should be replaced immediately. Fifthly, consider using a surge protection device. A surge protection device, or SPD, can help to protect CSST from lightning strikes by diverting surge currents to ground. SPD are typically installed at the electrical service entrance and at other points in the electrical system. There are different types of surge protection devices available, so it is important to choose one that is appropriate for the specific application. Installation of CSST should follow manufacturer's instructions explicitly, including approved methods for bonding and grounding. This is a key element in reducing the likelihood of damage from electrical surges. Some CSST manufacturers provide specific fittings and instructions for bonding their products. These should always be followed carefully. The type of soil around a building affects the effectiveness of the grounding system. Soil with high moisture content and mineral content is a better conductor of electricity than dry, sandy soil. If the soil around a building is not a good conductor, it may be necessary to install additional ground rods or use other methods to improve the grounding system. In some cases, it may be necessary to treat the soil with a conductive material to improve its conductivity. The local electrical inspector can provide guidance on how to improve the grounding system in areas with poor soil conditions. Another important aspect of CSST safety is proper installation practices. Incorrect installation can increase the risk of damage from lightning strikes and other electrical hazards. Some common installation errors include, firstly, using the wrong type of fittings. It is important to use fittings that are specifically designed for CSST and that are listed for the intended application. Secondly, over-tightening the fittings. Over-tightening the fittings can damage the CSST and reduce its ability to withstand pressure. Thirdly, not supporting the CSST properly. CSST should be supported at regular intervals to prevent it from sagging or kinking. Fourthly, running the CSST through unapproved areas. CSST should not be run through areas where it is likely to be damaged, such as attics or crawl spaces. It is important to follow the manufacturer's installation instructions carefully to ensure that the CSST is installed correctly. The manufacturer's instructions will provide guidance on the proper type of fittings to use, the correct torque for tightening the fittings, the proper spacing for supports, and the approved areas for running the CSST. It's important to remember that even with proper grounding, bonding, and installation, CSST is still susceptible to damage from lightning strikes. Therefore, it is important to take additional precautions to protect your home from lightning strikes. Some additional precautions you can take include, firstly, installing a whole house surge protector. A whole house surge protector can protect your entire electrical system from surge currents caused by lightning strikes and other electrical events. Secondly, unplugging electronic devices during thunderstorms. Unplugging electronic devices can protect them from damage caused by surge currents. Thirdly, staying away from windows and doors during thunderstorms. Staying away from windows and doors can reduce your risk of being struck by lightning. It's also worth noting that insurance companies may have specific requirements for CSST installation and lightning protection. Check with your insurance company to see if they have any requirements that you need to meet. Meeting these requirements can help to ensure that your home is properly protected from lightning strikes and other hazards. It's essential to have a clear understanding of CSST, its vulnerabilities, and the measures that can be taken to mitigate the risks. By following the recommendations outlined here, you can help protect your home and family from the dangers of lightning strikes and gas leaks. Remember to consult with qualified professionals for specific guidance related to your situation, and always adhere to local codes and regulations.